Welcome to AP Statistics. In this video, we're going to talk about box plots and how they can be used to explore quantitative data. So let's dive right into it. So when we're exploring exploring quantitative data, we have something called the 5-number summary. Now, the 5-number summary is a really cool set of 5 numbers. It's the minimum, the first quartile, the median, the third quartile, and the max. So those 5 numbers together are called the 5-number summary. And we could use the 5-number summary to break our data into quarters, because that's exactly what it does. So if we have our data and we say, all right, well, let's see here. Here's the minimum. Here's the maximum. The median's right in the middle. That breaks the data into 50% above, 50% below. Then Q1 breaks the middle of the bottom. Q3 breaks the middle of the top. So now we see our data gets broken down into quarters. That's pretty easy to do. Now let's talk a little bit about a box plot before I show you one. So a box plot is a graphical representation of the 5-number summary. The box represents the middle 50%. So the box is going to surround Q1 on the left, Q3 on the right. In the middle, or somewhere in between Q1 and Q3, not necessarily in the middle, is going to be a line that indicates the median. Lines, or whiskers as they're typically called, extend from the edges of the box to the most extreme points that are not outliers. If you have an outlier, we mark those with an asterisk or a dot, some special symbol to signify that they're outliers. And then your whisker, the lines outside the box, go to the next value that was not an outlier. Hopefully that makes sense. So let's take a look at a box and whisker plot right here. This is a very generic one just to show you where everything goes. Now first, beneath every box and whisker plot has to be a number line. You got to have a number line so that way you know where the numbers go. So you'll notice that we have a box here, and the box surrounds Q1 all the way to Q3, and then we put a box around that. And then inside of that box, we're going to put a line where the median falls. Now, you have to understand what I'm about to say. The median does not fall numeric-wise right in between Q1 and Q3. Data-wise, it does. So what that means, and that may be a little confusing, but that means from Q1, the left side of the box, to the median is 25% of data. From the median to Q3, the right side of the box is also 25% of data. If one side looks bigger, it does not mean there's more data. It means that that data is more spread out. The same number of values are on each side of the box. And boy, we're getting colorful here. But if it's wider, that doesn't mean more data. That means the data is more spread out. All right, I got to erase all that. It's getting too convoluted there. All right, then we have our whiskers. So again, first you have to establish if you have outliers or not, because those have to go first, because the whiskers go to the next highest or lowest points that are not outliers. So in this set of data, we obviously did have 3 outliers. Oh yeah, how do you find outliers? You use our fence system. So remember Q1 minus 1.5 times the IQR and Q3 plus 1.5 times the IQR. Those set boundaries. Any values below them are outliers. Any values above the upper fence is an outlier. So we notice here we did have 1, 2, 3 lower outliers. So this whisker went to the next value that was not deemed an outlier. It does not go to the fence. The fence is some imaginary number that's not part of your data. It does not go to the fence, please. And then over here on the high side, we obviously did not have any outliers. You notice no special marks. So that means that this end does go to the max. There was no values above it. All right, pretty cool. So what can we learn from looking at this data? What can we learn from looking at box plots? So the summary statistics and graphs of quantitative data can be used to justify claims about the data in context. Claims can be made about shape, center, and variability, also known as spread, that we could see in a box plot. But don't forget about histograms. Don't forget about dot plots. Don't forget about stem plots. You could see shape, center, and variability in those as well. A box plot is just another way that we could display the shape, the center, and the variability of our data. Now, before we take a look at a couple more box plots, let's make a couple more big points. The shape of a distribution impacts the center. We've already mentioned in other videos that if a distribution is relatively symmetric, then the mean and the median are going to be really, really close to each other. maybe not identical, but they're going to be really close to each other. If you're skewed to the right, the mean is going to go to the right. So it's going to be more than the median. Let me draw you a picture. It's skewed to the right. See, yes, there is a bulk of data on the lower side, because when you're skewed right, most data is to the left, but some data is to the right. But the data that is to the right are going to be really big numbers because they're bigger, they're to the right. And the mean, having to take all those values into account, is going to move up towards it. So where the median might be right here, 50% above, 50% below, the mean is going to be a little bit more than that because of the high values to the right. Same thing, but opposite happens if you're skewed to the left. If you're skewed to the left, the majority of your data is to the right. That's where a lot of your values are, those really high numbers. There are some low values down here, though, and the mean has to take those low numbers into account. So the mean's going to end up being lower than the median because the median's going to be right here, the 50-50 mark. Whereas because of those low values, the mean's going to go towards them. So how does this relate to a box plot? Well, in a box plot, we're going to be able to see shape, skewed left, skewed right, or symmetric. A box plot does not use the mean. Remember, a box plot uses the 5-number summary. One of them is the median. But if you see symmetry in your box plot, then you could assume the mean is going to be very close to the median. If you see skewness in your box plot, you could assume the mean is going to go towards that skewness. All right, now what about shape, or spread, because the shape of a distribution also impacts the spread. If data is relatively symmetric and unimodal, then the standard deviation is going to be pretty low because most of your data is near the mean. Let me draw you a picture. Here is symmetric and unimodal. Most of the data is in the middle. Very little data is very high or very low. So here, our mean is going to be very close to the center with the median. They're going to be pretty close to each other. And the standard deviation is a measurement of how data varies from the mean. Well, since most data is near the mean, this is going to have a lower standard deviation. So its S value is going to be lower. Whereas if we're skewed to the left or the right, the standard deviation is actually going to be higher. Because when you are skewed to the left, or that would actually be skewed to the right, or skewed to the left, that means your data is a little bit more spread out. Because those really high numbers or really low numbers are spreading the data out, and that's going to cause data to end up being further from the mean, which is going to make you have a higher standard deviation. Now let's see how we can actually see this in a box plot. Here are 3 box plots. Now these are all generics. We don't see the number lines. We don't see what these actual values are. They're just meant to be generic. But we can actually see on this first one how the left tail or the left whisker and the left box is wider. Remember, wider does not mean more data. It means the data there is more spread out. Every one of these parts contains 25% of your data. Wider doesn't mean more data, it means more spread out. So here, the left side of the data is clearly more spread out. We see a bigger chunk down here. The lower 50%, just look, to capture it all, I had to make a bigger circle. It's more spread out. So that is going to be indicative of skewed left. Down here at the bottom, we see the same thing in opposite, but skewed right. The right side of the box, the right whisker, are longer. Again, look at this. The lower 50% and the upper 50%. I had to make a bigger circle to capture it. It's more spread out. Wider doesn't mean more data. It means more spread out. We still have 25% of data in every one of those 4 chunks. So we see skewed right. Now here in the middle, we see that the left is very close to the right. The 2 boxes are not necessarily identical in width, but they're fairly close. That's a sign of symmetry, and that means that my median is right here. But guess what? The mean is probably pretty close to the median as well, because that's what happens when you're skewed. When you're symmetric. Too many S's words. Now, when you're skewed left, that means that the mean is going to be towards the left. So while the median is right here, the mean might be somewhere a little bit lower. Skewed right, here's the median. The mean might be somewhere a little higher. So box plots really do tell us a lot about the data. All right, here's a very specific example. So Mrs. Sanchez's period 1 math quiz results. So her class, I don't know how many kids are in a class, but maybe there's 50, 20, who knows how many kids are in her class. But they all take a quiz and she makes a box plot of their scores. So first, what are some things we could identify just by looking? The median. The median looks to be about 63, give or take 62, 64, somewhere around then. Q1, that's the left side of the box here. That looks to be just below 30, so maybe we'll sway 29. Then we have Q3. That's the right side of the box. That looks to be pretty close to 70. Now, I want you to notice the width of the boxes. This is way wider than this. Does wider mean more data, more test scores? Nope, it just means more spread out. There's still 25% of scores here and 25% of student scores here. The 25 in the yellow area are just more spread out. Same thing with the whiskers. This whisker and this whisker are a little bit different in length. On the right side, we're more spread out. All right, now there are no outliers here because we don't see any of those special marks. So that means the lowest kid had a minimum of 20. The highest kid looked to be about maybe a 93, 94, give or take. But that's what we see when we take a look at this box plot. So pretty cool, pretty nice. All right, here's one that compares two box plots. So the question was asked, is there a difference in the sugar content between name brand cereals and generic brand cereals? So name brand are like, your big brands, your Honey Nut Cheerios, your Rice Krispies, the name brands, whereas the generic brands are like, those the lesser name brands, the ones that sell them in the bags maybe. Okay, you get my point. So is there more sugar in name brand or generic brand? So we looked at many boxes of cereal, some name brand, some generic, and we recorded the number of grams of sugar per serving that it says on the side of the box, and we made a box plot of that data. Now, the one thing is I have no idea how many cereal boxes I looked at. Could be 20 versus 20 or 30 versus 30 or 50 versus 20. I have no idea. But if I simply said, hey, based on the data, based on center, which name brand or generic typically has more sugar? Well, look at the median. The median for the name brand is right around 13 grams of sugar per serving, where the median for the generic is 10. So based solely on center, name brand typically has more sugar. We could also look at the spread. Which one's more spread out? Clearly, the name brand is more spread out. Not only does their min to their max more spread out, but their interquartile range, the distance between the Q1 and the Q3, that middle 50% is also more spread out than the generic. The IQR for the name brand looks to be about 15 to 4. So that'd be an 11 grams of sugar for the IQR. Whereas for the generic brand, it's 12 to 8. That's an IQR of only 4 grams of sugar. That's a big difference. So clearly the name brand's more spread out. Other things we notice. For example, 25% of name brand cereals are higher than all of the generic brand. So think about that for a second. Remember, every one of these chunks represents 25%. So this 25% right here for the name brand is guaranteed to be more sugar than any of the generic brand cereals. That's kind of cool. We could also look at this data right here. Look, 50%, anything above the median is 50%. So 50% of the name brand cereals is higher than 75% of the generic brand. So we see here that the generic brand, 75% is below Q3. So 50% is above the median. So we see that the 50% here is way higher than the 75% here. So these are some questions that you may see on the AP test where they're talking about comparing two box plots, looking at percentages, and all you have to know is that every chunk represents 25%, and you can actually compare them. So again, comparing them, name brand way more spread out, generic less spread, and the name brand also typically has a higher amount of sugar. All right, the only thing I want to run with you right now real quick is how to actually create one of these box and whisker plots. Well, first, you do need your data. You need your 5-number summary, which you can get on a calculator. I'm going to make a video that you can watch for that. And the min is 10, the Q1 is 15, median 18, Q3 36, and the max 81. So I first made a number line, and I had to make sure my number line covers all my data. So I needed it to go from definitely 10 to definitely 81. So I went a little lower than 10, which is 0, a little higher than 81, which is 90, and I made my intervals go by 10. Okay, got to do that. And you can put your little marks there for 10, 20, 30, 40, 50, 60. Sorry, I'm not best at spacing this out, but it looks pretty good. All right, then we can go right away and put a line at the median. The median is 18, so a little bit below 20. Put a line at Q1. Q1 is 15, so that's going to be a little bit less than 18, right between the 10 and the 20. Can make a box around that. And boy, that's an ugly box. Sorry about that. And then Q1 is 36. 36 is going to be a little bit closer to 40 than 30. You get the idea. Just try to estimate here. And okay, now I cannot draw my whiskers until I check for outliers. Let's walk through that real quick. So I'm going to find my fences. The lower fence is going to be 15 minus 1.5 times the IQR. The IQR is simply the difference in between the Q3 and the Q1. So 36 minus 15 is a difference of 21. So there's my IQR. So 15 minus 1.5 times 21 is negative 16.5. Now my minimum is 10. So clearly there are no values that are going to be lower than negative 15.5. So that means I'm safe to put my lower whisker all the way down to the minimum of 10. All right, what about the upper whisker, or the upper fence, excuse me. So that's going to be 36 Q3 plus 1.5 times the IQR of 21. And 36 plus 1.5 times 21 is 67.5. Now, I know for a fact the max is an outlier. 81 is clearly more than 67.5, so I'm going to put a mark at 81. Little asterisk, little dot, something right there to indicate an outlier. Now, the whisker goes to the next highest value that was not an outlier. The problem is, I don't know that. Based only on the 5-number summary, I don't know that. I would need to have a list of my data to go back and look. Some kids think that the whisker goes to the fence. No, no, no. The whisker goes to the next fence, not an outlier. So maybe I go back to my data and I find out that the next lowest value was 72. Well, holy crap, that would also be an outlier because that is also more than 67.5. So I'm going to need an asterisk at 72 as well. And then the next value maybe was 61. Okay, 61 is not an outlier because it's not above the upper fence. So that is where my whisker will go. So that's a terrible straight line. Sorry about that. So you do need to actually see all of your data as well as knowing the 5-number summary in order to be able to determine how to completely make your box and whisker plot. Now, real quick, if I had to describe this data, I know it's generic, but there's no context here, but I'd say the shape is skewed to the right. The upper 50% from the median to Q3 and then from Q3 all the way to the max is way more spread out than the lower 50%. That's going to be skewed right. What about the center? The center is right around 18 because when you're skewed right, using the median as a center is a great idea. What about the spread? Well, the data does have a fairly large spread going from 10 all the way to an outlier max of 81. However, the middle 50% of data is actually not that spread out. The middle 50% ranges from 36 to 15. So that middle 50% of data is actually not overly spread out. So those are some of the cool features that we get from a box and whisker plot. And the last thing we could ask, and this is a very common AP question, is how does the mean compare to the median? Well, because I'm skewed to the right, the mean is going to be somewhere more than the median of 18. I don't know what it's going to be, 20, 21, 22. I don't know, but I do know the mean is going to be greater than 18 for sure because I'm skewed right. If I was symmetric, I'd say they're pretty simple or pretty similar. If I skewed left, I'd say that the mean is lower. But when you're skewed right, the mean is going to be higher. That's a great typical AP question. All right, I hope you learned a lot about box plots and that you could use them to explore quantitative data.